Welcome to Get Your FRQ On. This question is from 2019. It's question 5, and it is not calculator active. In the question stem, we have two functions, f and g, and we are shown the image of the region bounded between these two curves between 0 and 2. And in part A of the question, we are asked to find the area of the region R. Now, in order to do this, we have to understand which of the two functions is greater than the other one on the interval from 0 to 2. So I just plugged in h of 1, which is 6, and based on the graph, it should be obvious at that point that h of x is greater than g of x between x equals 0 and x equals 2. So the area of this region can be found by the integral a equals integral from 0 to 2 of h of x minus g of x dx. And then the functions themselves for h of x and g of x are not pleasant. So h of x is 6 minus 2 times x minus 1 squared, and g of x is negative 2 plus 3 cosine pi halves x. So we have to evaluate this integral, and notice that this is not calculator active. So this is a question, this particular integral, you would be expected to find an antiderivative for this by hand. So if you do that, right, we get 6x minus 2/3 of x minus 1 cubed plus 2x minus 6 over pi times the sine of pi halves x. And we need to evaluate that between 2 and 0. If you do that, you get a bunch of different terms, 12 minus 2/3 plus 4 minus another 2/3. There's a handful of terms here that cancel out because when you substitute 0 in, they just give you 0. But ultimately, in the end, you get 16 minus 4/3, which is 44/3. In part B of the question, we are given that cross-sectional areas taken perpendicular to the x-axis have area a of x equals 1 over x plus 3. And then we are asked to determine the volume of that solid. So the volume of the solid, if cross-sectional areas taken perpendicular to the x-axis have the given area function, we're going to integrate our a of x from 0 to 2. All right, so the volume would be the integral from 0 to 2 of a of x dx, which is the integral from 0 to 2 of 1 over x plus 3 dx. And then applying antiderivative rules, we get the natural log of x plus 3 evaluated between 2 and 0. And if we do that, the volume of the solid would be natural log of 5 minus natural log of 3. In part C of this question, we are asked to write a volume integral that could be used to find the volume of the solid formed when r is rotated around the line y equals 6. Notice we only have to write the volume integral. We do not need to evaluate it. So the line y equals 6 is actually above both h of x and g of x, except for the point where h of x actually touches y equals 6. So if we imagine this region being rotated around the line y equals 6, the outer region of the solid is going to come from the function furthest away from y equals 6, which is g of x. And then we're carving out another solid from the inside of this, which will reduce the volume. That will be generated from the function closer to y equals 6, which is h of x. So the volume integral that we need would be v equals pi times the integral from 0 to 2 of 6 minus g of x squared, right? That's going to be our big radius, minus 6 minus h of x squared, that's our small radius, dx. We do not have to evaluate this, thank goodness, that it would not be pleasant to do. But that is the integral we would need in order to find that volume.